Okay, we're going to do Friday's homework right now. I think I'm going to do this on separate paper though, so that I have room to show all my work. Okay, so the first one says find for the following parabolas, find the vertex, focus, directrix, and lattice rectum, and 2 points on the end of points of parabola, graph the parabolas. Okay, so number one, x squared equals negative 2y. If we wanted to make this look like our problems on the sheet, it would be x minus 0 squared equals negative 2 times y minus 0. So if you want to make it look like the one that's on your paper, this is what it looked like. So you'll see that the vertex is 0, 0. So let's go ahead and plot that. And let's go and write the vertex over here. We got to find all this stuff. So vertex is 0, 0. Focus. For this, since x is squared, it's either going to open up or down. And since this is negative, it's going to open down. So I'm going to write that. It's opening down. Because it's opening down, when we use this negative 2 to help us find our focus and directrix, we're going to set 4p equal to negative 2, and then divide by 4 and get 4 equals negative 2/4, which is really negative 1/2. So that means we're only going to go down a half, a point, and that's our focus. So our focus is 0, negative 0.5. Okay, so this is going down. Our lattice rectum is negative 2, which means you have to have a length. So the lattice rectum, again, is 2 units through the focus. So if you go 1 unit to the right and 1 unit to the left, right there at the half, those are your lattice rectum points. So it looks like 1, negative 1/2, negative 1, negative 1/2. I'm not going to make you write those, but those are 2 points on this parabola. So I'm going to go ahead and graph the parabola with my lattice rectum points. So I won't make you tell me these, but you better be showing me those. Make sure your parabola is going through those points. And then the directrix is a half a unit above the vertex, and that is a horizontal line because the parabola cannot touch this. Okay, so any other way you could draw that, it would hit the parabola. So it needs a horizontal, plus the directrix is perpendicular to your axis of symmetry, and your axis of symmetry is x equals 0. So let's say axis of symmetry is x equals 0, because that goes right through the middle of the parabola, and the directrix has to be perpendicular to that, so it must involve a y, and that's y equals positive 1/2. And you're done with number 1. Okay, so number 2. It says y squared equals 4x. So I'm not going to put the zeros in this time, but this does mean that the vertex is 0, 0, because there's no x in h. Okay, so there's your vertex. And the 4. So you're going to take 4p and set it equal to that 4 out front of the x, and then divide by 4, and p is 1. Now this one, because y is squared, is either going to open right or left, and since 4 is positive, it's going to open right. So if we take 1 unit and go to the right, that's our focus point. Our focus point would be 1, 0. Using this 4 again as a lattice rectum, a lattice rectum is a length of 4 through the focus, so you're going to go 2 units up, and you're going to go 2 units down. So we can actually sketch that parabola with 3 points like that. Okay, I'm not going to make you write those points, but if I did, it'd be 1, 2, and 1, negative 2. Those would be your lattice rectum points. And your directrix. Well, let's do your axis. Your axis is always going to be that line that cuts the parabola in half, so let's do that one first. Your axis is y this time. Y equals 0. So your directrix has to be perpendicular to that, so it has to be x equals, we're going to go 1 unit this way. So it's going to be x equals negative 1. And you're done. Number 3. So this one now has a center. Y plus 1 squared equals negative 2 times x plus 2 squared. It's already in the form I want. Just going to get my graph drawn here. So this one's vertex. You find the x, and the opposite of that number is negative 2. Find the y, and the opposite of that number is negative 1. And we're going to plot negative 2, negative 1. And write b. Your focus comes from setting 4p equal to the negative 2 right here. And so p is negative 1/2. This one, because the y squared is opening left or right, because this is negative, it's opening left. This is the left parabola, so that means we're going to go negative 1/2. Of course, I wrote the v right where I need we're going to put negative 1/2 to the left of the vertex. And that point is 1, 2, looks like negative 2.5 down 1. So negative 2.5 down 1. And the lattice rectum is 2. Don't like when you're doing the lattice rectum, I don't care if it says negative 2 or 2. The 2 is a distance, and so find your focus. Here's your focus. This is your V. So it's got to be a length of 2. So that's 1 this way and 1 this way. So this is going to be a skinnier parabola. And there's your parabola. Oops, sorry. There's your parabola. So your lattice rectum is negative 2.5, 0, and negative 2.5, negative 2. But we don't have to write that. Axis of symmetry is the line that cuts the parabola in half. So that's a y equals, looks like negative 1. It'll always be the y of your center. And your directrix is going to go a ½ unit the other way. And this one's going to be a vertical line because the axis is horizontal. These have to be perpendicular. So this is going to be x equals, and that looks to be about negative 1.5. And that would be done. All right, looks like we have 2 more. I think I'm gonna see if I can't squeeze these on the same page here. So number 4, we have x minus 1 squared equals 8 times y minus 3. So let me get a little graph in here. Hopefully my graph's going to be big enough. All right, so off to the side here, we have our vertex, which is the opposite of the number with x, which is 1, and the opposite number with y, which is 3. And this one is opening up because x is squared, and this is positive. So to find our focus, we're going to take this 4p and set it equal to 8, and p is 2. So we're going to go, since it's going up, our focus goes up. So our focus is going up 2. So that point is 1. Since we went up 2, be 1, 5. Our lattice rectum is 8, so we're going to go 4 units to the right and 4 units to the left. So this is a little bit wider parabola because the bigger the number out front of the y minus 3 there is, the longer the lattice rectum. So this has to be a length of 8, 4 on each side of the focus. So this is the y-axis, by the way. This is the x-axis. All right, now, the axis symmetry is the line that cuts this parabola in half, so it's going to go right through the x-coordinate of your vertex. So your axis is x equals 1, and your directrix is perpendicular to that, so it's y equals, and since p was 2, we're going to go 2 the other way, draw a horizontal line. That looks to be about y equals 1. So x equals 1, y equals 1. And that is number 4. Number 5. So this one you need to complete the square. X squared plus 6x minus 4y plus 1 equals 0. So let's group our x's. And anything that doesn't, because it's a parabola, because there's only one square term. Because this is a parabola and there's only one square term, anything that doesn't contain an x moves to the other side. So we're going to move this term over to the other side by adding it. We're going to move this term to the other side by subtracting it. So what's half of 6? You might be saying 3, and 3 squared is 9. So this is what we're adding to both sides. So if you complete the square, this is x plus 3 squared equals 4y plus 8. So we're almost done. The left side looks beautiful, but we need to take the GCF 4 out of this side. So this is 4y plus 2. So that makes our vertex negative 3, negative 2. And this one's opening up. So negative 3, negative 2, all the way over here. So I might not be able to fit this one in, but we'll try. This is negative 3, negative 2. That's the vertex. If you go back to the equation, take that 4, set 4p equal to 4. And p equals 1. So 4p equals 4 right there. P equals 1. So since it's opening up, we're going to go 1 unit up, and that's your focus. So your focus would be negative 3, negative 1, because we only went 1 up. Your lattice rectum has a length of 4. So find your focus, which is right here, and go 2 units right and 2 units left. So your parabola is going to look like this. So we're going to run into that other side a little bit. Your axis symmetry is this line right here. It cuts the parabola in half, so that is going to be x equals -3. It's going to share those points with the vertex and focus, which makes the directrix perpendicular to that. And we're going to go 1 unit the other way and draw a line. That looks to be about y equals -3. So 5 is done. So one more parabola problem looks like. So this one is y squared minus 2y equals 8x minus 1. So if you look at this problem, this one's going to be a left or right parabola because of the y squared. And anything that doesn't contain a y moves to the other side, and it's already moved over, so we didn't even have to do that. So we are going to complete the square here. We're going to take half of -2, and half of -2 is -1. -1 squared is 1. So we're adding 1 to both sides. So this is y squared. Oops. Let's go ahead and factor this. This is y minus 1 squared equals 8x. Actually, it's just 8x. So be careful here. There's nothing you can't really factor out, but you can do this so that you can get it to look like your formula. So your vertex is 0, because that's the opposite of number with x, and 1. This is opening right. So 0, 1 is the vertex. And we're going right. If you take 4p and set it equal to 8, do it over here. 4p equals 8. P is 2. So we're going to go 2 units right. That's your focus. So your focus is 2, 1. Let's see. Our lattice rectum is 8, so we have to go 4 up and 4 down. It's 1, 2, 3, 4. So our lattice rectum has a length of 8. And our axis symmetry is this line. It cuts the parabola in half, so that's y equals 1. Notice all the ones are shared here, because they're all on the same line. And your directrix, it has to be x equals, and we're going to go 2 units the other way. So that's x equals -2. And that one's done. I mean, the homework's not done, just the first 6 are done. Now we're on number 7. So number 7 is 4x squared plus 25y squared equals 100. So we're going to divide everything by 100 to get that equal to 1. You're going to have x squared over 25 plus y squared over 4 equals 1. So this is an ellipse that has a center at 0. Center 0. So the a squared is the bigger number in an ellipse, so the a squared is 25, which means a is plus or minus 5, and we're moving left and right because it's under x. Let's go off my graph a little bit here. So there's your 5s. Those are your vertices. Those are called your major vertices. So it's 5, 0, -5, 0 for major vertices. And your center was 0, 0. I forgot to write that. Your minor vertices, sometimes some people call them minor vertices, some people call them co-vertices. But b squared is 4. So b is plus or minus 2. So we're going to go up 2, down 2, and draw your best oval or a best ellipse. It should not look like a diamond. Just take your time drawing this. Make sure they're rounded. That's pretty good. Yeah. Put it over here. I don't want anyone to go through it. I have seniors. Now, did it say find focus? Yes, it did. So wait a minute. Let's go ahead and say our minor vertices are 0, 2, 0, -2. And your foci is c squared equals a squared minus b squared, which is 25 minus 4, which is 21, which is plus or minus radical 21. So the square root of 21, let's look, is about 4.58. So we're going to go. It's got to be on the major axis. So 1, 2, 3, 4. That's really close to that major vertices. So I'm just going to go over here. I just write F1 and F2 there. And then can you tell me what they are? So what did we just do? We added it to the x. So going to be plus or minus radical 21 and 0, because we don't have to put 0 plus because it's on 0. And those are your foci points. Okay, number 8. Let's do it down here. Number 8 is x minus 2 squared over 36 plus y plus 1 squared over 21 equals 1. So, it looks like the center is going to be 2, negative 1. My graphs lines aren't very straight here. Let me see if I can't darken this up. Looks like the actual axis. It's very important that we label x and y axis so I know if there ends up being more lines or something that we know which one's the x and y axis. All right. So a squared is, again, the 36. So a squared equals 36. So a is plus or minus 6. And we're going from the center here, 6 right and left because the 36 is under x. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it looks like the y squared, is that really? Let me make sure I wrote that down right. 21. We just did 21 right above this. So b squared was 21. So b is plus or minus radical 21, which was about 4.58, because we just got done doing that in the last problem. 1, 2, 3, 4.58. 1, 2, 3, 4.58. Okay. And draw your best ellipse. Okay, so there it is. What have I not said? I haven't said my vertices. Okay, so my major vertices were 6 beyond the center to the right and left, so we add it to the x. So if you add 6 to 2, you should get 8, negative 1. If you subtract 6 from 2, you should get negative 4, negative 1. Let's make sure that looks right. About 8, negative 1, about negative 4, negative 1, so I'd make sure I did it right. And then the minor vertices, it looks like we added radical 21 or 4.58 to the negative 1. So you have a choice. You can use a decimal or you can use a radical. So if you're using, since it's a radical, sometimes you can just do this. Do negative 1 plus or minus radical 21. That's okay with me. And your focus. C squared equals 36 minus 21, which is 15. So the foci is about, I don't know, what's 15? 15 is right under, it's got to be like 3.8 because 16 is 4, right? So we're going to go on the major axis about almost 4. 1, 2, here's 4, so let's go right inside that. 1, 2, 3, 4, but come right inside that because it's radical 15. So it's probably about right there. So how do I write those? Those run along the major axis. So you're going to take the center. You're going to take the center at 2, negative 1, and you're adding radical 15 to the 2. So it's 2 plus or minus radical 15 and negative 1. That's your foci. And number 9, we have to complete the square. I think I'm going to do this one sideways. No, I won't, because it'll be hard for you guys to see that. How about if I just do this on the back? 16x squared plus 25y squared plus 32x minus 150y equals 159. Okay, so this is an ellipse because 16 and 25 are different. Hi, how are you? And this is a positive. So we're going to group our x's. I like putting parentheses around these, and then we're going to put a plus, and then we're going to group our y's. Whether this is a hyperbola or ellipse, I'm putting a plus right there. Minus 150y. All right, so you have this. See it? This is a long one, so I don't know if I can get all this on this. Let me move this up so I can see all of this. All right, so let's take a GCF out. So we're taking a 16 out. So that's x squared plus 2x plus blank. Take a 25 out, and you're going to get a y squared minus 6y plus blank equals 159 plus blank plus blank. So what's half of 2? 1. 1 squared is 1, so we're adding 16 to the other side. Remember, because we have to do this. And then what's half of negative 6? That's negative 3. Negative 3 squared is 9. So 25 times 9, I believe, is 225. So complete the square. X plus 1 squared.
Good morning, Panthers. First off,
Y minus 3 squared.
Ladies first will not be meeting this morning. Wives move will be moving in this
159
meeting in Mr. Hamflick's room. And
plus
all
16
juniors must report for their ACT
is
test.
400.
Thank you.
Which makes sense because 16 times 25 is 400. Divide everything by 400. And this 25 and 16 are going to switch places here. So 16 goes into 400 25 times. Or if you want, you could just do like this. 16 divided by 400, because that's what the fraction is right here. You can punch it in, calculator, and press equals, and then press math, enter, enter. And that says 1 over 25. That's why there's a 25 in the bottom. All right, y minus 3 squared over 16, because 25 goes into 416 times, all equals 1, and we're ready to graph. So the center is negative 1, 3. The major vertices have something to do with the a squared, which is 25. Why is it so blurry? So a squared is 25 means that a is plus or minus 5. So we're going to go 5 to the right, 5 to the left, 5 left, 5 right. And what are those points? We just added 5 to the x. So negative 1 plus 5 is 4. Negative 1 minus 5 is negative 6. And there's your major vertices. Your minor vertices are going to be the square root of 16, which is plus or minus 4. So we're going to go from the center, we're going to go up 4. And we're going to go down 4. 1, 2, 3, 4. So your minor vertices, it looks like we added and subtracted 4 to the y-coordinate of the center. So if you add 4 to 3, it should have been a 7. If you subtract 4 from 3, you get a negative 1. That's not a great ellipse. Ooh, I missed that. Not the best one I've drawn. And your foci, c squared equals 25 minus 16. And that's 9. So c is plus or minus 3. So those go on the major axis, this is the major axis. So go 3 to the right, 3 to the left, which is easier on graph paper. Points for the foci. You just added 3 to the negative 1. So negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And there's your foci. So the ellipse portion is almost over. I need another piece of graph paper. Actually, I might be able to fit number 10 on here. Let's see if I can fit 10 on here. Focus is negative 4, 0. Vertices are plus or minus 5 and 0. This is what's given. So I'm going to do a little sketch here. If the focus is negative 4, 0, and the vertex is negative 5, 0, this is vertex, this is focus, and the other vertex is 5, 0, your ellipse is going to look something like this. So if this focus is negative 4, 0, there's another focus at 4, 0. So this is all about A's, B's, and C's. It's obviously one of these type 1 ellipses because of it's longer this way. So you can look at your formula sheet. I'm going to be giving you this formula sheet on the test. I'll be showing you here. So the reason I know it's this type right here is because it's just, well, I should probably draw a picture on this. Type 1, I already ran these off, but I'll probably have you guys draw these in class. This type 1 is going to open like this in the x squared. So anyway, you should be writing this down. All right, so it's this type, okay? So what do we know? We know that the center is 0, 0 because the center is the midpoint of the foci and it's midpoint of the vertices. So that's going to take this down to x squared plus y squared equals 1. Forgetting the squares and stuff like that on the test will cost you points, so don't do don't do that. So anyway, the A is the distance from center to a vertex, so that's 5. C is the distance from 0 to a foci, that's 4. So we know everything but B. So if we know A, we can put that in our equation, that's 25. So we're just looking for B squared. So we're going to use our foci formula. C squared, which is 4, that's 16, because that's 4 squared. A is 25, that's 25. So if we add B squared over here and subtract 16 over here, 25 minus 16 is 9. Put a 9 right there, and you're done. You just have to write the equation. It does not say to graph the equation, so that's it. Even though we did graph it, kind of. And number 11. Number 11 says your vertices are negative 5, 0, 5, 0, so very similar to the last one. And C is 2. Very similar to the last one. By them telling you that, you know that A is 5, and you also know that you have the same type. It means the center is 0, 0 again. So it's kind of like, just like the last one. I don't know, they didn't really make this one too different. A is 5 again, so this is 25 again. But the C is only 2 this time. Okay, so this time, what happens to the ellipse? All right, so C squared, we know is 2. So A is 5 and C is 2. We're finding B. So C squared equals A squared minus B squared. C squared is 2, so that's 4. A squared is 25 minus B squared. So B squared is 21 this time. And the ellipse section is done. And now we're going to do some hyperbolas. All right, number 11. Y plus 3 squared over 4 minus x minus 2 squared over 9 equals 1. Find the center. Okay, so the center is, I'm going to do it over here. The center of this hyperbola is 2, negative 3. Look, find your x, find your y, take the opposite. So I'm going to graph that. 2, negative 3. Center. Starting with the positive term. This is not the bigger number, but it is the positive number. So A squared is 4. So A is plus or minus 2, and these are your only vertices. We're going to go right. Oh, no, we're not going right. It's under the Y. Sorry, my fault. It's under the Y, so we're going up 2, down 2. So those vertices are 2, negative 1, and 2, negative 5. These are your vertices and your only vertices that you're allowed to list. Now, we do have some, like the conjugate vertices, or some people call them they're not really there, but they're there to help draw the asymptotes in the box. So we're going to take this 9, and we know that B squared is 9. So it's plus or minus 3. So from the center, we're going to go 3 to the right, but we're going to put an X there, because these are not your vertices, but they are going to help us draw our box. So we're going to sketch a box. I really wish I had a pencil right now. Try to make this box pretty light. You don't want it to stand out. The corners of the box is what's important. These are going to be points on your asymptote. So using a nice steady hand, draw lines from center through the center and the corners of the box. Like this. Let me sign my pass here. And remember, I almost went from the X, but you're not supposed to go from the X. You're supposed to go from the vertices. Remember, 2, negative 1? These were your vertices. So we're going to go up and down, because this is a type 2 hyperbola, because the Y is first. And that's what your hyperbola should look like. The only thing we haven't done is, does it say to list our asymptotes? It does say find the equations of asymptotes. Hopefully they want you guys going down there today. Is the ACT in the comments? Okay. All right, I have to finish this video and then I'll be with you. Actually, I'll have Ryan go over it with you. Let me finish this video. You mind just going over this quiz with him? Just by going over it, I'll give you some points. But you've already taken the retake. How about we start sitting in the front so you can listen to what I'm saying instead of messing around in the back? What? All right, so c squared. Let's do this one. First, let's do this. C squared, so we have these answers. I don't know where to do this work. Okay, c squared equals a squared plus b squared. So c squared equals 4 plus 9, and c squared equals 13, and the square root of 13 is about 3.6. So you're going to go up. It's got to be inside the bolas. So 1, 2, 3.6. Go back to the center. Count 3.6 the other way. 1, 2, 3.6. This is foci 1. This is foci 2. Okay, and then we have to list those. So what do? We went up and down, so we added to the center, -3 of the center. So your foci points are 2, -3 plus or minus radical 13. That's how you would list your foci points. So that's an answer. Now your asymptotes, it was type 2, so if your hyperbolas, this is type 2, right? See, so the y is first, right here. So here's the equation of asymptote. It's the a over the b. A over the b. So equations of your asymptotes. You're going to have y minus k equals plus or minus a over b x minus h. So y minus this y coordinate of center would be y minus -3 equals the a, which is 2, over the b, which is 3, and then x minus 2. So it's y plus 3. Now I'm going to separate this plus minus right now. I don't know why I'm writing sideways right now, but I am. So we're going to distribute the 2/3. This is just algebra right here. So subtract 3. And then -4 minus 3. So we have -4 minus 3. Math, enter, enter. So -13 is my y-intercept. Let's see if that looks right. -13 is about -4 1/3. So where's my x and y axis? This is my y-axis. My x-axis is right here. So it says -4/3. So 1, 2, 3, 4 1/3. Ooh, it's right there. That's the y-intercept. And the slope's 2/3. So you'd go up 2 over 3. And you'd be right on that line. So this one looks good. And then we're going to distribute the -2/3 to get the other line. So this is plus 4/3 now, and we are going to subtract 3. And then 4/3 minus 3 is this. And we will go to math, enter, enter. And get -5/3. Now -5/3, we just saw the decimal for that, is -1.6. So if you look at the graph again, if you go down 1.6, you're right there on that line. See that line? You're right on the line. And the slope's -2/3, you go down 2, right 3, and you'd be right on that line. Okay, so those lines look good, and those are your asymptotes. Hope we don't have too many of these. It takes a while. All right, so we have to complete the square for number 12. Let's go ahead and group the y's right now. Group your x's. Okay, so I'm looking at 12 right here. See number 12? Here's number 12. I group the y's. I group the x's. Notice my negative x squared is inside the parentheses with a plus sign, even though I know it's hyperbola. I'm putting a plus sign here because when I distribute this negative out, it'll become a negative. So half of negative 4 is negative 2. Negative 2 squared is 4. We're adding a 4 to the other side. All right, this time, this is y minus 2 squared. This one's ready. But this one, I have to factor a negative out first. So this is x squared minus 4x. Because when you take a negative out of these two terms, they both come their opposite. That's going to be tricky for some people. So half of negative 4 is negative 2. Negative 2 squared is 4. But we're not adding 4 to the other side. We're adding negative 4 to the other side. So this is going to be minus x minus 2 squared all equals 1. Because the 4's cancel. So if we divide by 1, you get this. So these both have 1's under them. But this is an up and down hyperbola. So this is a short one. So it's 2, 2. You're going up 1, down 1 for your vertices, but your co-vertices are the same thing. So this is called an equilateral hyperbola. So this box is really tiny. Your asymptotes are going to be tiny. And it's going to be up and down like this. That's your graph. So let's go over all the stuff that we just did. Our center was 2, 2. Our vertices, we went up 1. So that means we changed the y. So that's 2, 3. And we went down 1. So that's 2, 1. The foci was c squared equals a squared plus b squared, which is 1 plus 1, which was 2. So c is plus or minus radical 2, which is about 1.4. So if this is 1, 1.4 is right next to it, like that. So the foci points then would be, they all share the same 2 in the front. All that's the same. But the y-coordinate would be 2 plus or minus the radical 2. Those are your foci points. And your asymptotes, which is the pain in the butt part, is y minus k equals plus or minus a over b times x minus h. It's right from your sheet. So it's y minus the y-coordinate in the center equals plus or minus 1 over 1, which is just 1, and then x minus 2. So it's y minus 2 equals 1 times x minus 2, and y minus 2 equals negative 1 times x minus 2. So y minus 2 equals x minus 2. Add 2 to the other side, and you get x. So if you look at this, this is the y equals x line right there. The other one, if you distribute negative 1, add 2, you get y equals negative x plus 4, and that's your other line. And you're done. We got foci, vertices, center. I did that one kind of fast. I apologize. But this video is getting too long. So 13, we have 2y squared. I'm going to group right now. Plus 8y. And then plus negative x squared plus 2x. I'm just grouping them now. Equals negative 3. So let's look at this equation right here. I grouped the y's. And then I grouped the x's. And I moved the 3 to the other side. And that looks like this. So this one we're taking a 2 out. And this one we're taking a negative out. We already moved the negative 3 over. Now it's time to complete the square. So you have 2 y squared plus 4y. Half of 4 is 2. 2 squared is 4. Half of negative 2 is negative 1. Negative 1 squared is 1. And we are adding to this side an 8 and a negative 1. So this is 2 times y plus 2 squared minus x minus 1 squared equals 4. Divide everything by 4. Divide that 2 out front. This becomes a 2. This one, it stays a 4 because nothing cancels it. And you have equals 1. So yet again, we have another up and down hyperbola with the center 1, negative 2. So the center is 1, negative 2. Your vertices are going to be plus or minus radical 2. That's about 1.4 up, so not quite to the 0. The way that you list those points is, since we're going up and down and we're changing the y, means your x is the same, and you're going to write negative 2 plus radical 2, negative 2 minus radical 2. That's how you write them separately. You can write them as one order pair too if you want. All right, your fake ones, I should say, are 2 and negative 2. So if you make your box, make your box, asymptote. If I had graph paper, this would be better. So there's your asymptotes. It's supposed to be dashed. I'm sorry, these are supposed to be dashed. And this is up and down, so we're going to go up. And down. And your foci is c squared equals 2 plus 4, which is 6, plus or minus radical 6. So your foci, again, are up here somewhere. Square root of 6. Which one? Did I mark something wrong that's not wrong? Can bring it up here. There's 11, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. You do 9 factorial over. There's 3 S's. There's 2 T's.
I put NCR instead of that.
And there's 2 E's.
Yeah, I know how to put
And then you put that in your calculator. Square root of 6. What is the square root of 6? It's about 2.4. So we're going to go 2.4. So we're right above the x-axis there for foci. 2.4 this way. It's right here, foci. And the way that you would write them is they share the same x, but you go negative 2 plus radical 6 and negative 2 minus radical 6. Or you can write it as one order pair. Oh my gosh, do I have to go? Is that it? Don't worry about the asymptotes right now. I don't have time to do these. And the last problem, I have to do 2 more problems. And 14. Write the equation. Oh, can I put these on this paper? That was stupid. 14. Focus is 0, 6. And the vertices are, so this is your focus, and the vertices are 0 plus or minus 2. You don't have to sketch it, but it helps to sketch. 1, 2, 3, 4, 5, 6. That's a focus. This is a vertice. And this is a vertice. So that means the other focus is down here. This is going to be a hyperbola that does this, because the focuses have to be inside the curves. So this is called a type 2. It's the same one we've done 3 times now. They're all up and down. If you look at your sheet, it's this equation right here, where the y is first. So I think it's good if you write down your equation. And now we're going to fill these things in. So what do we know? We know that we know that the center is 0, 0. So we can go ahead and go to this. Okay, so center 0, 0. And looks like the A is 2, because if this is the center, if you count, this is A, and that's A. A is the distance from center to a vertice, and the C is the distance from the center to the focus, which is 6. So we know C is 6, so all we need to know is B. By the way, A is 2, so if you put that up here, that's a 4 in the equation. All we need is B squared. So we're going to go C squared equals A squared plus B squared. If you go over it, I'll give you some more points, right? Thanks, Evan, for coming in. Do you need a pass? Where'd you come from? So B squared equals 32. And you're just going to go put that in there and you're done. We don't even need to know what b is. We just need to know what b squared is. And 15, last one. Oh no, actually, it's not. This is b. This is 14a. This is 14b. So your foci are. Thank you, Ryan. Plus or minus 4, 0. Asymptote is the line y equals negative x. Okay, there's your focus. Now, these are not vertices. These are foci. This has to be type 1 right now because, and it gives you an asymptote. Ooh, this is going to be tricky. So, but I do know the center is 0, 0. So this is type 1. So this is going to be the x part first, and it's going to be minus. The x is going to be first. So what do we know? We know the c is 4. That's what we know so far. And we know this line. So in type 1, which this is, your asymptote is b over a, but it's got to be 1 over 1. Okay, it's going to have to be 1 over 1. So b is 1. So because it's a 1, these both have to be 1s. Because if it's b over a, it's 1 over 1. That's b and that's a. So 1 squared is 1, 1 squared is 1. Or is it in proportion to that? To think about this. A is 1. Let me see if that makes sense. Maybe we have to see which one makes sense. All right. So this is 16. This is not 1 plus 1. So this is going to have to be, okay, this is in a proportion of 1 to 1. But it's not going to be 1 to 1 because c squared equals a squared plus b squared. And these have to be the same thing because it equals 1. So what two numbers add up to 16? To be 8. So it looks like this would have to be radical. So that's 8 plus 8, that's 16. Because this is really 4 squared. I know this is probably beyond you guys, but the foci formula has to be true, and it also has to be true to the slope of the asymptote. The slope was 1, but it doesn't have to be 1 over 1. It could be 2 over 2, 3 over 3, 4 over 4, 5 over 5. It's got to be two numbers that add up to 16 after they've been squared. So radical 8 squared is 8, and radical 8 squared is 8, and that's 16. So it looks like A and B are both, A is radical 8 and B is radical 8, but if you square them, they should be 8s. So that if you did c squared equals a squared plus b squared, you would go 8 squared, or is it radical 8? I'm going with that. Don't worry about that. All right, I'm not going to give you one of those. And that's it. 48 minutes later.